Alright, in this video we're going to talk about adding and subtracting polynomial expressions. Right? So when you add and subtract polynomials, you do that by combining the like terms. And what we mean by like terms is like terms have the same variable raised to the same power. Right? So like an x to the third and an x to the third, those are like terms. You know, a 5x to the 7th power and a negative 12x to the 7th power, those are like terms because they have that same variable raised to the same power. Right? So there's two examples up here, one with adding polynomials, one with subtracting polynomials, and they're similar but a little bit different, just like addition and subtraction are similar but different. So the first one, addition, is pretty straightforward and pretty simple to do. You basically just have to identify your like terms and then combine them together. Right? So we have x to the third minus 6x squared plus 2x plus 4, that's our first polynomial, plus x to the third plus 5x squared minus 7x is our second polynomial, and those two are being added together, right, because there's that plus in between them. All right, so to add these polynomials together, I have to first identify the like terms. All right, so my first polynomial has an x to the third power. My second polynomial also has an x to the third power, right? So I'm going to add the x to the third plus the x to the third. Well, if I have 1x to the third plus 1x to the third, that's going to be 2x to the third power. Right? When we add polynomials, when we combine like terms like this, we basically identify which ones have the same variable raised to the same exponent. Those are the like terms. And then we either add or subtract their coefficients. Right? Remember, the coefficients are the numbers in front of the variable. So it's a 1x to the third plus a 1x to the third. We add the 1 plus 1 and get 2. That x to the third, we just keep that as x to the third power, right? We don't add the exponents here and make it an x to the 6 or do anything else. Right? That exponent stays the same. We just add or subtract the coefficients, the numbers in front. Right? Just like if you were to add, 1 apple plus 1 apple, that's 2 apples, right? That's not 2 apples squared. Right? That doesn't make any sense. Right? So 1x to the third plus 1x to the third is 2x to the third. Right? Just that number in front, that coefficient changes, not the variable in the exponent. All right, so that's our first like term. Our next term in our first polynomial is at minus 6x squared. And do I have an x squared in the second polynomial? I do, right? I have a plus 5x squared. Right, so I combine my x squared terms. I have a negative 6, I have a plus 5. Well, negative 6 plus 5 is negative 1. So I'm going to have a minus 1 or just a minus x squared. Right, remember, when the coefficient is 1, you don't have to put that 1 in front of the x squared. If you want to, it's fine. It's just not necessary. All right, so I have a 2x to the third. I have a minus x squared now. Now I go to my next term. All right, I have a 2x. Right, a 2x to the first power. And in my second polynomial, I have a minus 7x also to the first power. Right, so again, those are like terms because they both have the x raised to the first power. So I just do what the coefficients say. I have a positive 2. I have a minus 7. 2 minus 7 equals negative 5. So it's going to be minus 5x. Right? Once again, that variable, that exponent doesn't change. We just do what the coefficients in front of the variable say. Right? And then the last term I have here is that plus 4. Right? And so that's what we call a constant term. Right? We call it a constant because it doesn't have the variable attached to it, which means it doesn't change. It stays constant. Right? Plus 4 is just 4. Right? It doesn't change to anything else. Depending on what that variable is. 4 is always 4, it's constant, that's why we call it a constant. Right, so we have the plus 4 constant term here. In the second polynomial, we don't have any constants, right? We don't have any numbers there that are not attached to the variable. And so this plus 4, since I don't have any like terms to combine it to, it just stays a plus 4, right? It's still there. It doesn't just disappear because it doesn't have a like term. There's just nothing to add it to, so it's just still plus 4. Right, so this is my sum of those two polynomials. Right, I just identify each like term, put the x to the thirds together, put the x squares together, the x's, the constants, and whatever I get when I do that, that's what I get. All right, so that is the sum of those two polynomials. All right, so that's that first one for adding two polynomials. Again, adding, pretty simple. You just combine the like terms, do the adding, the plus or minus, whatever those coefficients say. Right, for subtracting polynomials, we're still combining the like terms, so it's a similar thing. And if you notice, this problem here is the same as the problem up here in example A. It's just instead of that plus in between, it has a minus. Right, so it's the same two polynomials, but now we're subtracting them instead of adding them together. Right, so the key thing when you're subtracting polynomials, and this is a real common mistake that people make all the time, we are subtracting this entire polynomial here. right? This parentheses around this polynomial means that whole thing is grouped together, and this minus out here applies to everything that's inside that parentheses, which means the first thing we have to do before we start combining like terms is we need to distribute this negative that's outside the parentheses, right? Whatever's outside that parentheses, if it was a minus, if it was a plus 2, we would have to multiply everything in the parentheses by 2. If there's anything outside that parentheses, you have to distribute it before you start combining like terms. All right, so my first polynomial here, the x to the third minus 6x squared plus 2x plus 4, right? Nothing there changes, right? The minus that comes after that doesn't affect anything that comes before that minus, right? So that's all the same as what it was before. But now when I distribute this negative into the second polynomial, it's going to be minus x to the third power. It's going to be minus 5x squared. And it's going to be minus negative 7x, which is going to make it a plus 7x, right? That minus negative, that double negative makes it a positive. All right, so basically when you have that negative in front of that second polynomial, what it does is it changes the sign of every term that's inside that polynomial. Anything that was positive becomes negative. Anything that was negative now becomes positive, right? So that's the key first step when you are subtracting polynomials. Or if you're doing any other type of problem that involves, a parentheses and a negative in front, you got to distribute that negative before you can proceed and start combining things together. Once we do that, though, right, once we distribute that negative to everything in the parentheses, now we proceed just like what we did up here. Now we just combine the like terms together. Everything's set up. We just got to identify what the like terms are and then combine them. All right, so I have an x to the third and a minus x to the third now. Well, x to the third minus x to the third is going to be 0, right? Because I have a positive 1x to the third and a negative 1x to the third. Those are actually going to cancel each other out in this case, right? Those are going to add up to 0. So my answer here is not going to have an x to the third term, right? You wouldn't write 0x to the third power. It's not wrong to do that because we have 0x to the thirds, but it's just totally unnecessary. Like, I don't have any x to the 7th power terms here, so I'm not going to write 0x to the 7th power. I'm just going to leave it out because it's not there. Right? So this x to the third minus x to the third, since it adds up to 0, I just don't include it in my final answer. All right, I have a minus 6x squared, and I have a minus 5x squared, so those are my like terms with the x raised to the 2nd power, and a negative 6 minus 5 is going to be negative 11x squared. All right, so again, when I'm combining the like terms, just like I did up here with addition, I just do what the coefficients say. Negative 6, negative 5, that adds up to negative 11. I keep that x squared the same. All right, I've got a plus 2x, and I've got a plus 7x. So positive 2 plus 7 equals 9. So that's going to be plus 9x. All right, and then once again, I have this plus 4 that doesn't have any friends, right? There's no like terms to combine it with. So I just keep that plus 4 on there. Right. Always kind of sad when you have a number that doesn't have any friends that you can combine it with. But numbers don't really have feelings, so you don't have to worry too much about it. I don't think the 4 cares. All right, so those are a couple examples there of adding and subtracting polynomials. Again, it's just combining like terms, identifying the variables with the same exponents, doing what the coefficients say to do, like adding or subtracting those numbers that are in front of the variables. And again, the key thing, especially when you're subtracting, you have to make sure you distribute that negative through that second parentheses. The most common mistake people make with something like this is to put that negative with the x to the third and then leave these other two things exactly as they are, right? But remember, notation in mathematics is very important. The parentheses around this entire thing here means that this negative applies to everything in the parentheses. You have to apply it to everything in the parentheses. You have to distribute that negative, or think about it as multiplying a negative 1 times all this stuff. Very important to do that, and is the biggest thing that people miss on a problem like this. So be careful for that and watch out for it.